Let's talk about jagged arrays versus multidimensional arrays. So right off the bat, I will go ahead and show you an example of a jagged array. Let's go into it and say jagged. We'll name it jagged, and then new int 10. So this is how you initialize a jagged array. And in this case, this basically has 10 spots. So what is a jagged array, right? A jagged array is basically an array of arrays. And it can have different lengths. So each array can have different lengths and can occupy their own block of memory. So let me show you an example. We can do something like this. Jagged 0, which is basically its first spot. We can say new int, we can say 90. Then we can go ahead and say jagged 1 equals new int, and we can say 80. Check this out. Basically, each spot has a new array. As I said, it's an array of arrays, but let's actually go ahead and see how it looks like. So we'll go through these and hover over it. So you see, first spot has an array, and that array has 90 spots. So if you go around, you'll go all the way. You see it has 70, 80, and then 89, which starts from 0. It goes all the way to 89. We already talked about that. Basically, it has 90 spots, and this one has 80 spots. These ones are not initialized, so they're just null. But here's the interesting part. So jagged arrays can act as a table-like structure, right? Which has uniform amount of rows and columns. You can basically treat it as a square or rectangle, but it doesn't have to be, because each and every spot can be of a different length. So that is jagged arrays. And .NET is basically optimized to be more effective when it comes to jagged arrays. So accessing elements could be a lot faster. Now let's talk about multidimensional arrays. So I will go ahead and create a 2x2 matrix. Actually, I'll say 10x10. How about that? So I will say matrix equals new int, and I will say 10x10. So in this case, we're actually initializing a 10x10 matrix, but the rows and the columns, they are uniform. So it's not like the first row has 10 columns and the second one has 8 columns. In this case though, we can do that, but for matrix, it is a table-like structure. So you cannot do the same thing that you can do with a jagged array. However, with the jagged array, you can create a structure like a matrix. So let's actually go ahead and see how this looks like when you're running it. If you run over it, you'll see that the matrix has 10 spots. So it's a 0, 0, 0, 1, 0, 2, right? So it has 10 spots for its first row, 10 spots for the second row, and so on and so forth, all the way down to the 10th row. So this is a true 10x10 matrix where it has rows and columns. And as mentioned, you can't do the same thing that you can do with a jagged array. So I guess the question here is, when do you use a jagged array and when do you use a matrix? So this is a very good question. And what it comes down to is performance and readability. A matrix has a nicer syntax. So if you are dealing with a structure that is a matrix-like structure and you need to have this uniformity, then use a matrix. However, if the size of your matrix is going to be very large, then jagged arrays are a lot more efficient when it comes to accessing. So in that case, you can use a jagged array and treat it like a matrix, because you can do the same thing that you want to do with the matrix with a jagged array. So you can use a jagged array and get that nice performance, yet you're not going to get a nicer syntax. However, performance is much more important in that case, so you can use a jagged array over a matrix. In our example though, in our Sudoku solver, we're going to be using a matrix as opposed to a jagged array, because a matrix represents truly what a Sudoku puzzle board is. It looks just like it, so we're going to be as closely representing it as we can. for readability purposes, and also it's not very large. It's 9 by 9, so we don't really care much about the performance here. That's why we are basically going to use a matrix as opposed to a jagged array. But this is the essential difference between a jagged array and a matrix, or just a multidimensional array.